Has the Earth always been as we know it today? This existential question answers a need to know our origins, our belongings, and to understand this world which surrounds us. Man hates ignorance. He therefore started to study this question very early on in order to understand the only known planet to harbor life. The history of the Earth begins 4.6 billion years ago. At that time, everything was different from what we know today. It is strange and hostile, and yet it will become so welcoming that one day man will be able to settle there permanently. How was the world around us formed? How did man, an organism among many others, manage to master and adapt his environment to his needs? Dear traveler, welcome. Through 4 videos, we take you on a journey through the history of the Earth, from its birth to the heart of our planet, from the beginning of its formation and throughout its evolution. You are here in the 4th and last chapter. Previously, we have recounted its adventure from its accretion to 250 million years ago. Today, we complete our journey. Every planet has a history. This is the history of the Earth. But before leaving for a new adventure, think of liking the video and subscribing to the channel to not miss anything. Thank you, and have a nice trip. Shortly after the terrible mass extinction that the Earth suffered, the huge continental plate that covers it, Pangaea, broke up. The Panthalassa Ocean has been sinking into the western part of Pangaea for a few tens of millions of years. This oceanic opening widens, advances towards the west, and a new ocean is formed, the Tethys Ocean. Pangaea is divided into 2 continental blocks. In the north, Laurasia, and in the south, Gondwana. The development of the Tethys Ocean has consequences on the climate, on the ecology, and on the geography of the Earth. The climate, which was predominantly continental, becomes oceanic. The rise in sea level is caused by the activation of new oceanic ripples. Biodiversity flourishes thanks to the flooding of new continental surfaces. Separated lands, however, limit exchanges between individuals. Eventually, some populations will be completely isolated and will become full species that will evolve and diversify on each continent. For now, the planet is empty in terms of biodiversity. The Great Permian Extinction left only a few survivors. Faced with these vast expanses to conquer, they have the opportunity to evolve and diversify. This is the beginning of a new adventure in the history of the Earth. The Tethys Ocean, its heat, and its dizzying depths are a godsend for the marine fauna. It is hot on Earth. The level of oxygen in the atmosphere is low. The level of CO2 is high, and the atmosphere on the planet is like a huge greenhouse. The flora has suffered the catastrophe of the Siberian traps, but it was much less brutal than for the animal world. Even if vast areas were devastated, in only a few thousand years, a flourishing vegetation decorates again the continental surface. The animals that survived conquered this new environment and settled there. Time passes, they will adapt, evolve, and new species will appear, creating new branches. This is evolution. Insects, on the other hand, continue to evolve, improving over the years. They are everywhere, already present by millions. Jawed butterflies, pollen crushers, flies already very similar to our current flies, or the first cicadas, and the first bugs share the air. "250 million years ago, the seas were repopulated by a multitude of new inhabitants. Among them, mollusks flourish fully, including belemnites and ammonites. The latter are present in greater numbers. Ammonites flourish and proliferate in waters that are 250 million years old. They are related to the class of cephalopods, which literally means feet in the head. Their feet are a kind of tentacles that surround their head. Several species of ammonites have been identified. They live rolled up in a spiral shell that is divided into chambers. Most of them are filled with gas or water to guarantee the buoyancy of the animal. To go down to the seabed, ammonites fill their lodges with water, and to go up to the surface they fill them with gas. The animal occupies the last compartment. Throughout their life, ammonites grow and build new lodges. These mollusks populate all the seas of the world, rather in the open waters than in the seabed. They present a great variety of size. Even if most of them measure a few centimeters or inches, some can reach up to 2 meters or 6 feet in diameter, the size of a tractor wheel. They are good swimmers. Alongside ammonites, belemnites have a very different shape, rather elongated, reminiscent of a javelin. Their head is provided with a beak and 2 prominent eyes. Their 10 tentacles have hooks and suction cups that allow them to catch their prey. Some species have a pocket of ink that they release to conceal their escape from predators. "15 million years later, small groups of archosaurian reptiles took over the ecological niches left vacant after the previous mass extinction. In the seas, hybodonts are found in large numbers. These fish were initially small, between 20 and 30 centimeters, or about 10 inches, and fed on tiny prey. A few million years later, they grew to a size of 3 meters or 10 feet in length. Thanks to their great capacity to adapt to salt water, they diversify. They develop teeth, allowing them to tear and crush. The class of condycthrians, distant cousins of today's sharks, are at the top of the food chain. But in front of them, new marine inhabitants are trying to make a place for themselves underwater: the reptiles. Some families are more like aborted evolutionary attempts, like placodonts. These marine reptiles feed on hard prey, shellfish or crustaceans. At the beginning of their appearance, they resemble iguanas, only bigger, since they reach 1 to 2 meters in length. In order to protect their bodies, placodonts develop bony plates on their backs that resemble a carapace. At the end of their evolution, they look more like our current sea turtles. Their size allowed them to ward off the first predators, but over the years, new reptiles, larger and more ferocious, appeared, causing the disappearance of placodonts. Other reptiles, on the other hand, had a long and grandiose reign, such as the ichthyosaurs. These animals frequent the seas of the blue planet. The oldest ichthyosaurs resemble finned lizards, while the most recent ones resemble tuna, but their characteristics remain unique. Their leg bones have evolved into swimming paddles and are reminiscent of a corncob. Their vertebrae resemble an ice hockey puck, and their eyes are encircled by a bone called a sclera ring. When ichthyosaurs dive and swim, the water exerts pressure that can distort sensitive parts such as the eyes, so the sclerotic ring strengthens the eye and gives the animals highly developed eyesight for their size. Ichthyosaurs measure from 70 centimeters or 30 inches to 20 meters or 65 feet in length. They are fond of belemnites, fish, and other marine organisms. Like all living things, they need to breathe. Although their oxygen consumption is low, they have lungs and must regularly come to the surface of the water to breathe. Ichthyosaurs are viviparous. Their eggs are not laid, but incubate in the genital tract of the female until they hatch and release their young in the open sea. The latter have subsequently acquired the ability to regulate their temperature. Ichthyosaurs move by swimming in a particular way. They undulate their whole body like lizards, and can thus accelerate easily to hunt or flee. Their more recent representatives, which are more like tuna, only undulate the posterior part of their body. This evolution in their way of swimming generates an important modification of their living environment. If, at the beginning, they were confined to the continental shelf, from now on, they ply the great waters of the oceans. It is, moreover, a generalized evolution. The fragmentation of the Pangea generates the dispersion of the marine fauna, which colonizes the high sea. On Earth, the surviving families of the previous extinction are the most widespread. At the top of the food chain, archosauromorph reptiles dominate. The more basal ones give rise to the archosaurs, and then emerge the pterosaurs. Pterosaurs are insect-eating flying reptiles, of which there are 150 species. For a long time populated only by insects, the air environment welcomes vertebrate animals. The Quetzalcoatlus is one of the largest specimens that can reach 12 meters or 40 feet wingspan, the equivalent of a small passenger plane. It has an elongated head, a long neck, and its tail is almost non-existent. The wing of the pterosaur is formed by a membrane of skin, connected to the hind limb, and supported by the fourth finger very elongated. In order to remain light during their numerous flights, pterosaurs have hollow bones. These animals fly over the forests of ginkgo and ferns in search of food. Since they do not have a highly developed olfactory center, they use their vision to flush out insects, fish, and birds. Although they are comfortable in the air, pterosaurs also frequent the aquatic environment and move around on land. Their feet are webbed, and they adopt a quadrupedal gait to move. On land, the Archosaurian lineage produced the first crocodiliforms with Protosuchus. This animal has an appearance very similar to that of crocodiles, with a large mouth decorated with powerful teeth and a long tail. The lineage of archosaurs gave birth to the first dinosaurs a little later. This is still a far cry from the giant predators we imagine when we think of dinosaurs. The Euraptor is one of the first known dinosaurs to have appeared on Earth. It later gave birth to the long-necked sauropods. It is about 1 meter or 3 feet long and 40 centimeters or 16 inches high, the equivalent of a large dog. It has been called the dawn hunter. It is the fastest animal of its time. It is omnivorous and feeds on other reptiles, insects, but also on all sorts of other foods that provide it with proteins and vitamins. The Colophysis is a bit bigger than the Euraptor. It can reach up to 3 meters or 10 feet long and 55 centimeters or 20 inches high. Its large tail occupies half of its body. Thanks to its narrow mouth, it catches small prey quickly. When hunting in a pack, like our modern wolves, it attacks larger prey. These different species shared the land with the first herbivorous dinosaurs, which were larger and more numerous. Among them, the flatfish is an animal that measures up to 10 meters or 30 feet in length and can weigh up to 4 tons. Its diet is mainly composed of plants. Thanks to its very sharp and robust teeth, it crushes the plants that it extracts directly from the tree. Its long neck, composed of 10 vertebral elements, gives it strength and power to defend itself and allows it to pull plants even from the treetops. Next to the first dinosaurs, the mammalian reptiles are largely represented by the order Therapsids, but their population tends to decrease due to the emergence of new branches during this period. This does not prevent the Lystrosaurus and the huge Lysowicea from roaming the wilderness. The Lystrosaurus is a mixture of mammal and reptile. It measures 1 meter long and 1.5 meters high. Its fangs protrude from its upper jaw, which gives it a fearsome look. It has a beak that resembles that of turtles, ideal for chewing plants and satisfying its needs as a large herbivore. It sometimes crosses the path of the Lysowicea, an enormous animal, which reaches the size of our current elephants. This herbivore uses its long beak to catch and crush vegetation. The Lysowicea is the prey of carnivorous archosaurs and is regularly hunted by them. The first mammalia forms appear a few million years later. They are the intermediaries between cynodonts and mammals. Under the appearance of our modern shrews, the Megazostrodon goes out at night to feed on insects and lizards. It is the prey of the first dinosaurs and must therefore be careful. Its small size, about 10 centimeters or a few inches, allows it to easily take cover. Adelabasileus is the oldest known ancestor of proto-mammals. It has in its ear a cochlea with a place close to that of the modern mammals. It is the link between the Therapsids and the mammals that will soon appear. All these small animals live alongside formidable carnivorous predators. This is why most of them have adapted to life at night. In its skull, its cortex is more developed than that of the reptiles of the time, and it has a neocortex which ensures the cognitive functions. These attributes require a higher energy consumption. They must feed on energetic foods such as herbs, fruits, and insects. Two large groups of dinosaurs dominate and are differentiated by the anatomy of their pelvis. They are named Ornithischians and Saurischians. Saurischians have a pubis directed forward. They are, for the most part, carnivores, but we also find in this group the huge sauropods herbivores with long necks. The Ornithischians, as for them, have a pubis directed towards the back, what evokes the basins of the current birds. They are all herbivores. Mammals seem to have been forgotten during this long period when dinosaurs predominated. And yet, our distant mammalian ancestors, tiny and fearful creatures, lurked in the shadow of the giants. These primitive mammals have reason to be afraid. Dinosaurs diversified, expanded, and pushed the anatomical limits of life on Earth. They occupy most of the ecological niches, and what is left to mammals is small, dark, like caves, caverns, hollows in trees, or underground life. Surviving in such environments imposes constraints on size and lifestyle. but also an overdevelopment of the senses. Smell, sight, and hearing allow them to have a nocturnal life, which is less dangerous towards predators who are less active there. The organs of the senses being concentrated in the head, this induces a larger brain size compared to that of reptiles. And this is not all. The brain-burning energy that must be constantly renewed, specific adaptations appear. Mammals have warm blood and a coat that isolates them. The constant need for energy requires protein-rich food, such as insects or other invertebrates and plant seeds. These foods must be quickly digested to release energy as quickly as possible. This is how sharp teeth appear. Thanks to their dagger-sharp, powerful and sharp teeth, mammals now catch and kill insects, crush hard shells. These teeth are operated by strong jaw muscles. The means of reproduction evolves. While the eggs of reptiles and birds have already seen considerable progress with the appearance of the protective shell, this system remains limited, since the egg must be large enough to allow the newly born animal to be sufficiently developed to fend for itself. In addition, eggs and newborns attract predators. Mammals take a different approach. They keep and feed the embryo in the mother's body to ensure a better start in life. Although this method limits the number of offspring and depletes the mother's resources, it has enough advantages to become the primary mode of reproduction. The forces that had enabled the formation of Pangaea a few million years ago are working hard to break it up. The first signs of the opening of the Atlantic Ocean are felt. The Earth's crust floats on the mantle, which is made of molten rock. The continental plates move, which causes an active circulation of magma. The more Pangaea breaks up, the more volcanic activity intensifies, until exceptional quantities of lava gush out on the surface of the Earth. A new mass extinction begins. Monstrous jets of burning steam come out of the bowels of the Earth. The entrained debris rises to more than 1,500 meters or 5,000 feet above the ground. A fiery cloud surrounds the fauna and flora. Animals try to find refuge in the heights or in the water. But the fragmentation of Pangaea has only just begun, and the consequences will intensify. On the edges of the future Atlantic Ocean, volcanic activity is intense. In time, it will form an immense magma province that will cover 11 million square kilometers, more than the size of the United States. Millions of animals succumbed. The Megazostrodon nests with its young in a burrow. Its small size allows it to take shelter and survive the hecatomb that will follow. It is now lava that flows from the heart of the Earth. Through all the cracks that have formed, flows of magma escape. The cracks can reach several tens of kilometers or miles in length. It is therefore an ocean of flames that flows on the surface of the Earth. Everything in its path at that moment is decimated, annihilated. The lava continues to gush out for months, for decades. The eruptions that cover the Earth with a layer of lava now have a toxic effect on the atmosphere. The gas dissolved in the magma rises to the surface, lowers the pressure, and diffuses into the Earth's atmosphere. The carbon dioxide level increases powerfully. The temperatures rise. On land and in the sea, the heat is unbearable, but the worst is yet to come. The level of oxygen in the atmosphere drops dramatically. The face of the Earth is changing. New cracks appear. The Pangaea is torn apart. 50,000 years after the beginning of the eruptions, the Earth shows a sad landscape. The abundant and lush vegetation has become non-existent. What once existed has dried up. The fires continue. The sky is tinged with red. The atmosphere is polluted, rich in carbon dioxide and poor in oxygen. In addition, there are ash storms that swallow up the few remaining survivors in their path. Then mixed with water vapor, these ashes give rise to acid rain. The little vegetation that remains is eradicated. The rains carry the corpses of flora and fauna into the waters. The ocean becomes a giant garbage can. The carbon dioxide dissolves in the water, making it acidic in turn. The plankton, the base of the food chain, is affected this time. The Earth is unrecognizable. Famine strikes without exception. Bacteria proliferate. Pangaea is totally transformed. The cracks extend over thousands of miles and miles, and the amount of magma spilled reaches 2 million square kilometers, almost 1 million square miles. It is only 500,000 years after the beginning of the catastrophe that the eruptions stop. Pangaea was a distant memory, and the Atlantic Ocean was born. In total, more than 75% of the species disappeared. The toll on Earth was tragic, but the ocean suffered even greater losses. The coral reefs have almost all disappeared. The planet is emptied, and yet the world as we know it today was born. Distinct continents are now established on the surface of the Earth. Our future now depends on the few survivors of the catastrophe. The air is unbreathable, and the carbon dioxide level in the atmosphere has never been so high. And yet, a few early animals have managed to survive this cataclysm and adapt to this environment. On land or in the seas, it is the hecatomb, and the calm dominates. Two continental blocks are formed, Laurasia and Gondwana. It is in this miserable environment that the marine and terrestrial fauna and flora will have to develop. The advantage is that many ecological niches are now vacant. The misfortune of some always makes the happiness of others. If when Pangaea was still in place, the climate remained dry in its center, it becomes hot and humid, following its fragmentation. The vegetation takes advantage of this new environment, favorable to its blooming. The abundant jungles do not delay to dress the face of the earth, and to revive the papillae of the herbivores. They become numerous and of respectable size. These herbivores become quality prey for carnivorous predators that also reach disproportionate sizes. The reign of the dinosaurs begins. They established themselves on the planet until 66 million years before our era. On land, many archosaurs are still present. They live side by side with large dinosaurs, like the Diplodocus and the Brachiosaurus. The Diplodocus is a giant that measures up to 30 meters or 100 feet long, the equivalent of a basketball court, with a gigantic neck that can exceed 6 meters or 20 feet in length. Its head appears proportionately tiny, housing a brain the size of an orange. Herbivorous by nature, it catches vegetation with its long and fine teeth arranged in a rake on the front part of its jaws. Its tail consists of 80 vertebrae and measures 14 meters, or more than 45 feet. Its 4 columnar limbs support its substantial weight, but it also relies on its tail to lift its body and pick up conifer branches up to 15 meters or 50 feet high. Diplodocus regularly crosses paths with its size rival, the colossal Brachiosaurus, another herbivorous giant. The latter has a similar appearance: large body, long neck, and very small head. It moves slowly through the vast forests of conifers and ginkgos. Although herbivores populate the Earth generously, they also become prey for theropod dinosaurs, which also spread all around the globe. Carnivorous monsters of exceptional size, threatening, like the terrible allosaurs, megalosaurs, or ceratosaurs. The Allosaurus literally translates as strange lizard because of its apparent bumps on its skull. It is quite large compared to other theropods, reaching up to 9 meters or 30 feet in length. It is ferocious and feeds on meat from weaker animals. Its robust limbs with powerful claws are totally adapted to hunting. Its tail allows it to balance itself against the substantial weight of its body. But the theropod dinosaur that remains the undisputed superstar of dinosaurs to this day is the Tyrannosaurus, also known as T-Rex, literally the king of the tyrant lizards. This active predator treads the Earth's surface with strides of up to 3.75 meters or 12 feet. From its height of 4 meters to 6 meters, or 16 feet, it uses its olfactory senses to locate its food. Tyrannosaurus is one of the most violent and terrifying creatures that ever existed. Its elongated head alone reaches 1.5 meters in length, or almost 5 feet long. Its teeth measure 30 centimeters or 11 inches from tip to root. Its very short upper limbs are topped by claws and are very useful for grabbing and holding its prey. Other animals have to be careful with this carnivorous monster. The battle rages on Earth. In the midst of huge dinosaurs, smaller species are adapting to survive. Some evolve and get wings. This process is done slowly. They would have been running animals, which, by waving their arms, the beginnings of wings covered with feathers, would have succeeded in accelerating enough to lift themselves off the ground. The species that brings to light the first winged dinosaurs is the Archaeopteryx. This animal is covered with feathers, except on its legs, head, and occiput. It has a long tail, an extension of its spine, and claws on its feet and on the 3 fingers of its forelimbs. It looks more like a reptile than a bird, but Archaeopteryx is an intermediate form between reptiles and birds. The appearance of feathers occurs placed initially to ensure a better insulation. Then, the feathers lengthened and ensured, in addition, a locomotor role. But Archaeopteryx is not yet fully adapted to flight. Its bones are dense, which gives it a weight too high to maintain itself in the air. The seas of the time have reefs in places that support diverse species of fish and a wide variety of marine life. Rudists, a group of marine bivalve animals, play an essential role in the development of these reefs. Frequenting warm, shallow waters, they filter seawater to feed on suspended organic particles. The rudists live fixed on the seabed with the help of one of their valves. They can reach up to 50 centimeters or 20 inches in diameter. While some live alone, others form real colonies. Placed against each other, they associate with corals, sponges, and algae to build real reefs. Laurasia and Gondwana are the 2 continental blocks present. Laurasia splits into 2 parts and reveals the future North Atlantic Ocean. 5 million years later, the southern part also opens. The Earth begins to take a familiar appearance, The climate is rather warm because there are no ice caps. The level of the oceans is high, and the temperature of the latter reaches about 10 degrees higher than our current oceans. Marine reptiles still dominate in large majority. Ichthyosaurus gave way to a newcomer, the terrifying Mosasaurus. This marine animal can reach the impressive size of 17 meters or 55 feet in length. It lives in the open ocean, several kilometers or miles from the coast. It moves by undulation, like the current crocodiles, which requires a lot of energy. It feeds on fish, birds, sharks, turtles, but also on other animals of the mosasaur group. In the air, the small pterosaurs now show quite respectable sizes. The Quetzalcoatlus measures 15 meters or 50 feet in wingspan. On land, the huge dinosaurs still dominate. New species appear, like the Triceratops. Adorned with 3 large horns on its head and a bony ruff, it is intimidating and can protect itself in case of attacks from other dinosaurs. It is not uncommon for it to have to defend itself from the huge T-Rex. Possessing at least 30 rows of teeth, this herbivore can tear up and crush even the most perennial plants. The mammals are there, small and discreet in the shadow of these giants of nature. In the animal kingdom, they have no importance at the moment. Flowering plants called angiosperms appeared as the climate became more humid and the atmosphere became richer in oxygen. They settle in places where conifers have not succeeded in establishing themselves. They are characterized by the presence of ovules inside grains which are contained in a closed cavity. They colonize at first the humid places when they gain the undergrowth of floodplains, the coastal swamps. Barely 30 million years after their appearance, they are already diversified and abundant and rapidly occupy all available ecological niches. The vegetation landscape was profoundly modified, and the ecosystems evolved strongly. Insects, which were present long before flowering plants, specialize in part as consumers of pollen, an energetic commodity, very rich in protein. Moving from flower to flower in search of food, they spread the pollen that sticks to their legs without knowing it. A fruitful alliance between flowers and insects is established. Herbivorous animals develop and diversify, but also granivores, frugivores, and insectivores. A few tens of millions of years later, the terrestrial ecosystem is totally transformed. The forests that remained became covered with colors, fruits, and berries. Flocks of pollinating insects parade in the middle of this vegetation. Huge herbivorous dinosaurs feed on all this food during the day, and small lizards, birds, and mammals are busy eating the leftovers at night. It is now more than 160 million years since the immense and majestic dinosaurs dominated the Earth. A world that has been slowly built up and is about to be annihilated, marking the 5th and last great crisis of life. No animal can see the danger coming. It is about to fall from the sky, slyly, at the speed of several kilometers per second. Billions of tons of asteroids are ejected. One of them is heading towards the Earth, like a real bomb. The shock is terrible. The meteorite hits so hard that a crater of 30 kilometers or 20 miles deep is drawn. An energy of a monumental intensity is released, causing the transformation of the rock of the Earth's crust into liquid element. Within a radius of 60 kilometers or 40 miles around the impact, the water turns into water vapor, and animals are immediately killed. Within seconds of impact, the shock wave reaches the ocean before dissipating. Everything in its path is literally vaporized. The consequences will soon be felt. The impact of the meteorite causes an earthquake of unparalleled intensity. The animals that did not fall into the crevices try to find shelter, but the catastrophe does not stop there. A wall of water, as big as a mountain range, rises and falls on the coast. The tsunami spares no one. On land and in the sea, everything is swept away, washed away and thrown on the shore. As the earth tries to catch its breath, the rocks that were propelled during the impact fall back. A shower of whole pieces of the Earth's crust falls on the Earth for several hours. The temperature of the atmosphere rises to more than 500 degrees Celsius and 930 degrees Fahrenheit in places. All creatures are vulnerable to the cataclysm. The planet is unrecognizable. Billions of animals will die. In the seas, 76% of species and 15% of families will become extinct forever. On the continents, 6% of families will disappear. Although the most famous crisis, the Cretaceous extinction, is nevertheless the most modest in terms of extinction rate. Biodiversity is still heavily impacted. Ammonites, large marine and terrestrial reptiles, disappeared, and the field was left open for small mammals to multiply and grow. Several months after the impact, the Earth undergoes a return to cold. The heat released by the meteorite has generated large quantities of carbon dioxide, which absorbs the heat. The Earth is about to live a long winter before finding a more stable climate. India, which was part of Gondwanaland, was slowly separated from the continent a few million years ago. It was wisely heading south, but was deflected and oriented north. As the plate crossed the Tethys Ocean, it passed over a zone of hotspot volcanism and saw its course accelerate. Its sudden displacement leads it to Asia, which it violently collides. India sinks under Asia at a speed of 2 centimeters or 0.8 inches per year. As a result, its crust is lifting and overlapping like scales on top of each other. India's crust thickened, and a mountain range was formed several million years later, the Himalayas. Northern India is compressed and loses 1,000 kilometers or 620 miles of extension. The fragments ejected from Asia will give the Southeast Asian bloc the archipelago of Indonesia and the Japanese archipelago. The face of our current planet continues to be assembled in the manner of a puzzle. The Earth is perpetually subject to earthquakes and volcanism. A strong volcanic episode that started around 60 million years ago releases a large amount of CO2. The lower atmosphere and ocean waters warm up initially. In the long term, the increase in greenhouse gases causes a rapid and generalized warming over the entire surface of the Earth. Ocean surface waters rise by 5 degrees Celsius, or increase by 9 degrees Fahrenheit. Greenland, Alaska, and Siberia are being covered by subtropical forests. This warm and humid environment is conducive to the development of life and coincides with an evolutionary radiation of mammals. The large extinct reptiles have left free niches, and mammals intend to take advantage of it. Some animals will develop to the point of mastering swimming or flying, like whales, dolphins, or bats. Primates, horses, and primitive deer start their different lineages. Birds multiply, and some species reach impressive dimensions with more than 2 meters in height. Insects and flowering plants continue to evolve with each other. In the Frankfurt area of Germany, a violent volcanic eruption leaves a large, deep crater open. Quickly occupied by the waters of a lake, this crater shelters an abundance of fauna and flora, allowing life on the surface. Amidst 1,000 diverse species of plants and animals, a small mammal stands out as the oldest common ancestor between the lineage that led to humans, monkeys, and lemurs. Darwinius massillae, better known as Ida, is morphologically close to present-day lemurs. It measures 1 meter, or 3.2 feet in length, and weighs between 650 and 900 grams, i.e., between 1.4 and 2 pounds. It is herbivorous and feeds on seeds, leaves, and fruits. It has a particularity. Its thumb, opposite to the other fingers, allows it to grasp, which brings it closer to primates. It also has no claws on its fingers, normally used by lemurs, and has a bone structure on its feet, the talus, which is similar to that of monkeys. It is situated before the separation of the 2 lineages, leading on one side to the monkeys and on the other to the lemurs. The life that remains in this crater lake is suddenly wiped out, probably by upwelling of carbon dioxide from the bottom of the lake. The animals are subjected to a rapid death. After the warm period, ocean circulation and plate tectonics lead to a cooling of the Earth. A current prefiguring the Gulf Stream weakens and sea ice gradually settles around and over Antarctica. It accumulates to the point that mountain glaciers are formed. A current that thermally isolates Antarctica is established, the Antarctic Circumpolar Current. It is the most powerful current on Earth. This current connects the oceans in the southern hemisphere and plays an important role in the circulation of waters of different salinity and temperature. It is cold, contains dissolved gases, and is one of the main reservoirs of CO2. The complete opening of Antarctica permanently cuts off ape populations from the New World, the Americas, and the Old World with Africa, Asia, and Europe. Some primates that remained on African lands managed to reach the American continent. Did they cross the Atlantic Ocean on floating natural rafts, or did they travel through chains of emerged volcanoes? The method is still unclear, but they settled in the forests of the New World. They will later be at the origin of tamarins, marmosets, or other howler monkeys characterized by their tails that wrap around the branches. The platyrrhines owe their name to the shape of their nose, which is flattened and equipped with a thick septum and large nostrils directed towards the outside. The catarrhins, or Old World monkeys, arrived from Asia on the African continent. They owe their name to their nostrils positioned on the sides. Africa appeared to them as an ideal place to live, and they gave birth to 2 different groups. The Cercopithecids, equipped with a tail that serves as a balance, and the hominoids without a tail. These last ones know a consequent development almost entirely concentrated in East Africa. "20 million years ago, the first proconsuls appeared. These quadrupeds use their forelimbs of identical length to climb trees. They will diversify and give birth to species of all sizes. It is at this time that the group of hominids appears, which gathers the current chimpanzees, gorillas, orangutans, and the man. 18 million years ago, the African continent and Asia collided. This collision will have an impact on the evolution of human history because 2 million years later, the seas are lower and the apes can then move to Eurasia. Western and Central Europe were then covered with luxuriant forests, an environment that favored the evolution of Old World monkeys that gave birth to the gibbon. The mode of movement by hanging from trees is widespread. Their arms are longer than their legs, and their hands are larger, with curved phalanges. As these monkeys straighten up, their pelvis and spine also become more rigid. Toumaï, ancestor of the man. The hominin lineage separated from the great ape 7 million years ago. Toumaï, which means hope of life, is the oldest known hominin representative. The region of Chad, where Toumaï was found, enjoyed a generous climate at the time. In the heart of savannas teeming with life and forests bordered by lakes, Toumaï, a small being of about 1.20 meters or 4 feet for about 30 kilos or 60 pounds evolved. Other species live alongside him, such as crocodiles, elephants, small rodents, fish, and wild pigs. Facing them, predators and scavengers include species close to hyenas and felines. Toumaï and his fellow creatures did not have an easy life. Despite their probable bipedalism, they are not adapted to running, although they can also run by leaning on their phalanges. Unlike chimpanzees, they do not have large canines to defend themselves, and therefore rely on their sense of smell, hearing, and sight to protect themselves. Their group spirit is also an asset. They are certainly vegetarian, with a diet based on fruits. Toumaï has primitive features and a cranial capacity equivalent to that of the chimpanzee, which does not prevent it from possessing considerable intelligence and a certain social structure. Toumaï is a unique mixture of morphological characters, different from what is observed in chimpanzees and the ancestral species of man. 6 million years ago, Orrorin roamed the lands of present-day Kenya. With both simian and human characteristics, the features of its humerus and femur bring it closer to modern man than to Australopithecus. It is clearly bipedal and arboreal, as shown by its curved phalanges. It feeds on fruits and is the prey of fearsome predators, such as large carnivores. It lives in an environment of dry evergreen forest, interspersed with wetlands. A little taller and heavier than its ancestor Toumaï, some measure 1.4 meters or 4.5 feet, weighing nearly 50 kilograms or 110 pounds. A little after Toumaï and Orrorin, the Ardipithecines lived just before the arrival of the Australopithecines. At that time, fire was not mastered, and living conditions were harsh. Tools had not yet been perfected. Bipedalism is again invoked for this genus. These 3 species that lived between 7 and 4 million years ago are at the base of our phylogenetic tree. They are a bit of an intermediary between the primate ancestors and the Australopithecines. The Australopithecus genus is found mostly in central, eastern, and southern Africa, in savanna areas near rivers and lakes. It is not before 2.5 million years that they migrated to Asia, then even later to Europe. The oldest Australopithecines are qualified as gracile. They are small in size and have a smaller brain than the following ones. Their jaws are finer than those of the paranthropes, the most recent representatives, and allow them to eat an omnivorous diet. As early as 2.5 million years ago, the most recent Australopithecines appeared, described as robust. Their massive jaws and large teeth allow them to feed on tough foods such as roots and tubers. Despite their small size, about a meter or 3 feet, and a brain no larger than that of a monkey, they have mastered bipedalism permanently, and some also climb trees with ease in the forested and wooded areas they inhabit. At night, they are able to build themselves a shelter of leaves. They eat fruits, leaves, insects, and sometimes meat. Australopithecines, whose name means Great Apes of the South, reigned for 2 million years. The animal and plant environment remained particularly stable during this time. They have a substantial supply of game among herbivores, elephants, giraffes, wild pigs, and small rodents. Their activities are organized around hunting and gathering. However, they are limited in hunting due to their poor equipment. The Australopithecine group was made famous by the discovery of Lucy in 1974, which was then the oldest hominin fossil discovered. Near the Awash River in Hadar, Ethiopia, several hundred bone fragments of lower limbs and jaws belonging to a single individual were found at an excavation site. It is the first time that such a large proportion of bones from the same individual is found. 52 of the 206 bones that make up the skeleton of an Australopithecine. The study of her pelvis confirmed that she was indeed a woman. Lucy has many simian characteristics: her flared rib cage, a large stomach, and consequently, a vegetarian diet. Lucy is about 1.10 meters or 3.6 feet tall and weighs about 25 kilograms or 55 pounds. Its joints, shoulders, long arms, and short legs testify to an arboreal life in parallel to its bipedalism. This discovery totally changes the conceptions of the origins of the human lineage, but it will still take some time before we arrive at modern man. Before 2.5 million years ago, the two Americas were home to very different faunas. The Central American Sea separates the two continents of North and South America. The waters of the Pacific and Atlantic Oceans mix. At the bottom of the oceans, a pressure is exerted, causing the Pacific plate to rush under the Caribbean plate. The pressure and heat that occur during the collision form volcanoes under the seas, visible in the form of small islands that emerge. The movements of the two plates cause the seabed to rise above sea level. Over time, the open spaces between the newly formed islands are filled in with sediment until a complete closed isthmus is formed between South America and North America. This is the Isthmus of Panama. The creation of a bridge between the two previously separated lands promotes a migration of plants and animals called the Great Interamerican Exchange. Organisms from South America reach the north, such as porcupines, opossums, anteaters, armadillos, and pangolins. Conversely, Horses, deer, elephants, and raccoons from the north settled in South America. For 1 million years, this transfer remained equal in exchange. Then, the mammals of the north continued to live and settle in the south, but those of the south became extinct or few in number in the north. 2.4 million years ago, new hominids appear, whose morphology is sufficiently different from that of Australopithecines living at the same period. They form a new genus, the Homo genus, to which our species Homo sapiens belongs. But it will be necessary to wait a little more before the latter appears. 3 main criteria distinguish the Homo genus: an exclusive and permanent bipedalism, a cranial capacity that became more important, accompanied by a flattened face, and the implementation of cultural activities such as artistic creations or the use of fire. Homo habilis is the first representative of the Homo genus to appear. It measures between 1.30 and 1.50 meters, that is, between 4.2 and 5 feet, and weighs between 30 and 40 kilograms, that is, between 66 and 88 pounds. It is a little larger than the Australopithecines. Physically, its teeth are smaller. It has elongated arms, sturdy legs, and curved phalanges. His hand is not freed from locomotion, and he still retains arboreal abilities. With Homo habilis, the production of tools intensified considerably, hence his name, skilled man. His diet became richer in meat, and he became omnivorous. As a perfect scavenger, he uses his tools to cut the meat and break the bones of the bodies of large mammals to extract the marrow. Appearing in the African cradle 1.9 million years ago, Homo ergaster took a decisive step in the history of the human lineage. He left the branches of trees and evolved essentially on the ground. This new mode of locomotion changes considerably his way of life. He appropriated fire and carved complex tools such as bifaces. Homo ergaster is an excellent walker and can even run over long distances. From the top of its 1.55 to 1.70 meters, that is to say, between 5 and 5.5 feet, and its 60 kilograms, or 130 pounds on average, it resembles more the modern man. It makes, for the first time, exits out of Africa with the aim of finding meat, which is necessary to him in order to nourish its brain and body in growth. Homo erectus is the first hominin with a brain volume exceeding 1,000 cubic centimeters, approaching that of humans, who average 1,350 cubic centimeters. This implies a strong need for meat. Its teeth, smaller than those of other hominin species, are also adapted to this new diet. It measures between 1.50 and 1.65 meters, or between 5 and 5.4 feet, and weighs, on average, 50 kilograms or 110 pounds. Although he was not the first to venture out of Africa, he was the first to travel very long distances, thanks to his fully mastered bipedalism. He set up camp as far as Asia and Europe. Homo erectus mastered fire and made tools carved in stone, such as symmetrical bifaces, axes, and scrapers. He created a real society gathered around fire. The hunter-gatherers form a real group within which each one takes care of the others. It is in this social and family environment that Homo erectus takes care of his descendants by providing them with the energy necessary for the development of their brain. Of a more massive and stocky aspect with rather short arms and legs, the Neanderthal man resembles morphologically the current man. He measures between 1.50 and 1.70 meters, or between 5 and 5.5 feet, and weighs between 50 and 70 kilograms, or between 110 and 150 pounds. Its cerebral volume can reach up to 1,750 cubic centimeters, that is to say, more than that of the Homo sapiens. It is gifted with emotions, skilled in handling tools, and capable of dialogue and creating a culture. He practiced funeral rites, which shows that he apprehended death as a stage in his existence. After its appearance in Europe, it occupied all of Eurasia, from the British Isles to the Russian plains, via the Middle East. It is capable of adapting to very different environments and significant changes in climate. It coexisted for some 10,000 years with Homo sapiens, but then disappeared. The human lineage differentiated from other bipedal hominids 2.4 million years ago. Homo sapiens made a late entry into Earth's history, but his footprint and success are remarkable. 200,000 years ago, the species to which all humanity belongs, the only survivor of the other Homo, settled on the planet. He measures between 1.50 and 1.75 meters, or 5 and 5.7 feet, and weighs between 50 and 70 kilograms, or 110 and 150 pounds. His skull is rounded, his chin bony, and his skeleton light. In spite of difficult beginnings, it manages to colonize the Earth. He organizes himself, assembles himself, and settles in fixed places. He settles down. Hunting and gathering, which until then had been a matter of survival, gave way to agriculture and animal husbandry, which ensured stable food resources. Homo sapiens learns to master the natural environment which was previously rather hostile to him. This capacity of adaptation allows him to spread over all the regions, even the most difficult, of the planet. He shapes the landscapes and takes in abundance wood and other materials for his comfort and his needs. His success is such that his population will not stop increasing. Just like Neanderthal man, Homo sapiens buried his dead. As populations grouped together and interacted, culture spread, notably with the development of various forms of art through paintings and statues. Science and technology spread, leading to a better knowledge of nature and the design of quality tools. Homo sapiens spreads and replaces the other human species, which become extinct at its contact, without knowing exactly the reason. The last Neanderthals are observed in the Iberian Peninsula 28,000 years ago. Homo sapiens remains the only species of the genus Homo on Earth. From now on, cultural evolution takes precedence over biological evolution. Symbolic thought and art literally explode. It develops ceramics, invents new weapons such as bows and arrows, and assegai thrusters. All hominins share the common character of bipedalism. This posture is a major asset that allowed the liberation of the hands, making them available for the elaboration of tools. But the sitting position is also largely contributed to perform tasks using the hands. When they are freed, they become creative. The human hand has adapted. The thumb has developed in opposition to the other fingers. The wrist joints generate a firm grip. The fingers can fold around an object to adapt to its shape. The evolution of the nerve centers and the tactile sense influences the development of the hand and gives it useful skills and sensations. In spite of the physiological evolution of adaptation to its environment, the newborn of modern man keeps certain archaic reflexes, some of which will persist throughout life, such as the breathing reflex, the yawn, the sneeze, the fluttering of the eyelashes, the cough. The hypnic jerk is a reflex that translates as a jerk during sleep to catch up with the branches. Over thousands of years, modern man domesticates plants and animals. He settled in the Middle East in the Fertile Crescent to develop agriculture and livestock. He developed an economy of production, no longer of predation, a sedentary and urban habitat, the use of ceramics, metallurgy, and the wheel. And finally, he invented writing, which marked his entry into history more than 5,000 years ago. His sedentary life constitutes a radical turning point in the history of humanity and a revolution in the environment. Natural environments were modified, first to a limited degree in villages, then on the scale of entire regions. The herds multiply, and their immoderate appetite for vegetation is the reason for the natural landscapes. Agriculture and livestock are deployed with increasing intensity. Man nibbles the forest to obtain timber and firewood. He develops environments more suitable for his livestock and his crops. The natural space is no longer wild, but artificial. During its 5,000 years of history, Homo sapiens multiplies its numbers by a factor of 1,000. A growth of the population, coupled with an unlimited consumption. The Earth, which ended up being shaped geologically in the image of the one we know today, gave him free rein to develop. It then crisscrossed the entire planetary surface. But it is during the last 2 centuries that it increases its knowledge in an exceptional way. Its technological part grows and becomes more complex. It consumes energy and raw materials in a bulimic way, a management of the resources not sustainable in the long run. The planetary pollution generated is so consequent that it could lead to the next mass extinction, of which it would itself be a victim. Animal and plant species are confronted in nature with the destruction of their ecosystems by the activities of modern man. Global warming is endangering the natural balance between air, water, animals, and plants. It is too late to turn back the clock, but far from too late to act and prevent it from getting worse. Human intelligence and technology are opening the doors to a possible future. Homo sapiens is now leading his evolution. He is able to change his way of life and to exploit the planet's resources in a rational and measured way. Because the Earth is far from having said its last word, the history of life on its surface is still going to know many evolutions.